I'd like to start off with a quick land acknowledgement here before we get going. I want to thank and acknowledge the territory of the Anishinaabe Nation, the people of the Three Fires known as the Ojibwe, Ottawa, Potawatomi Nations, and give further thanks to the Chippewas of the Saugeen and the Chippewas of Nawash, known collectively as the Saugeen Ojibwe Nation, as the traditional keepers of this land. I'd like to also encourage us all to consider the history of this land, what it means for those of us living on the land today, and what it means for future relationships and what we want those to look like going forward, whether that's relationships between Indigenous peoples and settlers or humans and our natural world. For those of you who don't know what the Bruce Peninsula Biosphere Association does, I don't blame you because we do a lot of different things. I'm sure if you don't know exactly what we do, you know at least one of the things that we do. In general, we work in conservation projects here on the peninsula, and we also work to raise awareness about these things, but also do concrete projects working on conservation initiatives. So I'm going to give you a few examples of things that we do, and I'm sure you've heard of at least a couple of them. So the first one, Bayside Astronomy, that happens on normal years. It hasn't happened since 2019, but it normally happens down at the Lions Head Marina. A bunch of volunteers bring their big telescopes out, and in our beautiful dark sky community up here on the peninsula, they enjoy some stargazing. Before COVID times, we were getting about 2,000 people per year come down to the marina and get some free stargazing. It's pretty exciting. Invasive species removal, primarily around Phragmites. So between a partnership between the Biosphere Association and the Nature Conservancy of Canada, about 1,300 plots of invasive Phragmites have been removed on the peninsula, and that's all volunteer based, funded by a few grants, but mostly volunteer. Eco Adventures is our social enterprise that caters to both visitors and locals of the peninsula, giving world-class tours, adventures around the peninsula. They were actually rated in 2020 as a TripAdvisor best of the best for getting so many 5-star reviews, which sounds pretty good. I don't know exactly what that means, but I think that's a good thing. The Six Streams Initiative, or around water quality, there's a few different projects with this. One is putting up fencing and different watering systems to keep cattle out of streams on the peninsula. It's also providing homeowners with grants to replace their old septic systems. And there's some also water monitoring programs that have been going on since around 2012 as well. And there's lots more that goes on. The Red-Headed Woodpecker Project is what's going on this year. Connectivity forest strategy, and then the Gravel Grand Fondo, which is actually happening in just a couple weeks. It's a lighthouse to lighthouse gravel bike race that happens on the peninsula as a fundraiser for the Biosphere Association. If you'd like to donate, we are a registered charity, and this is how that donation amount breaks down to. If you'd like to donate, you can do that on our website if you like the sounds of any of those things that we're doing here on our beautiful piece of land that we call the peninsula. The other project that I didn't mention there is the one that we're here for tonight, and that's the Climate Action Grant. So my position with the Biosphere is funded through the Climate Change Canada, and it's a grant that it aims to create a community climate action plan on the peninsula, but also aims to have direct action, getting people to shift to more climate-friendly technologies like the heat pump, which is why we're here tonight, of course. A quick little overview of what's happening climate-wise on the peninsula. First of all, Canadians themselves are about the fifth worst emitters per capita on the planet, with about 15.3 tons of CO2 per year. North Bruce Peninsula emissions is about 33 million tons of CO2 per year, 50% of that coming from personal transportation, i.e. your car, and 34% of that coming from buildings, which is primarily heating and cooling. Again, why we're here tonight. So far, as we know right now, there's about 25 to 30 EV owners on the peninsula and about 100 heat pumps, although that second one's a bit more of a guess. It's a hard thing to actually nail down what that number is, but according to Eric, there's more and more coming every week, which is good. We're going to move on to the presentation here, but before we do, I had a quick poll to give you guys to get us into the heat pump mindset. It's just a couple of questions here, and if you could answer them, it would give us an idea of kind of where we're at familiarity wise with heat pumps. So just take a couple of seconds there, put your answers in. Press submit.
Funny.
Looks like that. I have a couple more seconds, a few more. Looks like maybe that's all we're gonna get here. And that. See what our results are here. Everyone can see those results. We got pretty good spread of familiarity there. And most people said, please, that they would like me to stop talking. Okay, that's good. A few new builds, kind of midterm replacing their heating systems, 3 years. Some people are looking for one right away before the snow flies. All right, that's great. So I'm going to hand it over to Eric here, but to do that, I gotta stop sharing for just a second. And switch it over to, bear with me here. Gotta find Eric's presentation, there it is. How's that look? Can we see? Okay, Eric, you can see that?
I can see that. It's not in the presentation. Oh, there we go.
Here it goes.
Perfect.
All right, I'm gonna hand it
All
over
right.
to you, Eric. Thanks, everybody.
Okay, I think we can move off of this first one. You may want to jot down that phone number, but you know, it's up to you. We have 24/7 days a week emergency response. And what we're going to talk about today is we're going to go over these topics. So, you know, everybody wants to know what's a heat pump. The history of heat pumps has changed quite a bit over the last 30 or 40 years. Relative operating costs, everybody's interested in that. Various types of heat pumps. Some cautionary points that you need to pay attention to. We're going to touch a little bit on the federal rebate. And if you can kind of take note of the questions, email at the back. You can email me at any time, and I'm happy to explain anything in this presentation or any other questions. I think we've had a couple of questions before the presentation, which I'll address during the presentation. Okay, let's move on, Ryan. All right, so most people are familiar with how an air conditioner works. And basically what happens is it pulls the heat from inside your house and it actually sends it outside to come out of your outdoor unit, making you nice and cool in the house. But if you were to put your hand over your air conditioner outside, it's quite warm. Another example of this is on an old refrigerator where they had the coil at the back of the refrigerator. It's always very, very warm because it's pulling the heat out of the fridge to keep your food cold, and it pumps it outside the fridge towards the coil on the back. So in an air conditioning situation, the evaporator is actually inside your house, and the condensation side of it, the heat out, is on the outside of your house. So the way a heat pump works is it just reverses that. It's in backwards. So what happens is it pulls heat in from the outside and dumps the heat inside your house during the condensation process. We'll get a little bit into that, but I don't want to, I mean, I'll feel free to answer any questions, really technical questions that you have if you email me. Let's move on, Ryan, thanks. Next, yep, there we go. So again, we've got an air conditioner running backwards. So normally in your air conditioning mode, inside the house is your evaporator, outside the box is the condenser. For a heat pump, they've got a little handy thing called a reversing valve, and all it does is turn the flow of everything backwards. So now the outside of the house becomes the evaporator, which gets cold because it absorbs heat. And the inside of the house is your condenser, which gives off the heat and in heat pump mode makes you warm. Okay, let's move on. So here's another diagram of that heat pump. Again, on the right-hand side, they've got pictures of a warm and a blue arrow going in there with, you know, a variety of temperatures. It sends the heat onto the inside. Your furnace is blowing hot air out the top. Again, as it reverses in the summertime, in cooling, the cooling cycle, it's absorbing the heat from inside the house on the bottom left, and it absorbs it and it sends it outside and it expels it out the box. So, you know, the value of a heat pump is not only do you get heat in the wintertime, but you stay nice and cool with very good air conditioning in the summertime. So it's kind of a 2-for-1 special. Okay, let's move on. So some people are probably familiar with heat pumps. They were pushed back in the 70s. There was a big push for electric. There was a lot of electric furnaces out there that had heat pumps attached to them. The efficiency, the technology was very poor back then. And a lot of people remember paying unbelievable amounts of electrical bills back in those days. The heat pump helped a little bit. Generally, it stopped at about 0 degrees, and then the electric furnace would kick on full force, and people would wind up with $600, $700, $800, $900 bills. Some of those were because the heat pump actually stopped working and people didn't realize that. And the other part is back in those, the efficiencies were very, very poor. When we look at this chart, this is it shows the two efficiencies, SEER and HSPF. We'll get into that a little bit more, but before 1980, your SEER was 6 or less, HSPF was 5 or less. We have some stats for 2015. It's much better today, much, much, much better. Okay, let's move on to the next one, Rand. So here we talk about those metrics. So whenever you're looking at a heat pump, you're going to get 3 performance metrics. You're going to get the SEER, the COP or the EER, and the HSPF. The HSPF is specific to heat pumps. The SEER is the seasonal energy efficiency ratio for air conditioning. Right now, the minimum SEER in Canada is 13. If you remember back to the previous chart, I mean, it was much lower in the past. 10, 15 years ago, a premium air conditioner unit was 13 SEER. Now that's the bottom. You can't get any lower efficiency than 13 SEER. So again, what it is the cooling output divided by the total electricity. Greener Homes wants 18 SEER or greater. That's both the current federal rebate and the past 2 Ontario provincial rebates that have been on. So 18 SEER in the traditional air conditioner heat pump is quite an expensive unit, but the prices have come down drastically. The COP-EER is the coefficient of performance, energy efficiency ratio. It's just another metric similar to the SEER or the HSPF. I don't really look too much at that. You know, if you're an engineer, that can be important, but generally they follow along with the SEER and the HSPF. For a heat pump, your heating seasonal performance factor is very important. So the minimum out there that's allowed is a 6.5. 6.5 is not very good for the heating. Some units claim as high as 16.5, which is extremely efficient for producing heat. And greener homes generally wants over 9.5. A lot of companies highly recommend that anything 10 or over is of great value. That gives you the electrical efficiency, producing the heat, to make it very worthwhile to run your heat pump instead of your fossil fuel furnace, such as oil or gas or what have you. We'll go into this a little bit farther later on. Let's see the next one, please, Ryan.
So just to clarify there, Eric, the SEER refers to the cooling, so the air conditioning efficiency of the unit, and the HSPF refers to the heating efficiency. Is that right?
Correct. Yep. That's exactly right. Okay, so this is a nice little website. You can jot, I'll give you a couple seconds if anybody wants to jot this down. It's got a lot of very good information on costs. And this is Manitoba Hydro. And, you know, feel free to jot that down quickly. Give you a couple of seconds, and then we'll move on to a quick snapshot of what it says. Okay, let's move on there.
I can also share that link afterwards.
Okay, so here's pardon me.
Sorry, I was just saying I can share that link afterwards too if people are interested.
Okay, so here's where the province of Manitoba went and did theirs, and Manitoba's it's got pretty good winters, I think, compared to Ontario, and they shared. So heat pumps or air source heat pumps, your average annual cost is like $1,200 for heating. Ground source, actually $994 to $1,200 for heating. The cold climate one, we'll talk a little bit about that later on. That's the one that Canadians should be considering because it gives the better performance at the lower temperatures. And the only thing that's better is the ground source or the geothermal. So I'm sure that some people are familiar or have done their research with geothermal. Geothermal is an excellent system. The only drawback or the decision to make against an air source is the initial installation costs and the area of land required in order to sink those underground coils. So the value of the air source cold climate heat pumps, it has very similar performance and much lower cost and much easier to install, where you don't need a field in order to put your underground coils in. But the ground source heat pump is a fantastic system. As you go across there, you have high efficiency natural gas furnace. Again, natural gas is a very inexpensive way, but it is a fossil fuel. So these prices, I'm sure, do not reflect a fossil fuel tax. I'm not sure how everybody feels about the future of fossil fuel taxes, but I'm sure that they're not going anywhere real soon. And again, any type of fossil fuel, I think we realize is a non-renewable resource, or it doesn't renew very fast. And while electricity, I think, is considered a fairly quick turnaround renewable resource, which is kind of where we're going with the electric versus the fossil fuel. Again, you can see a variety of heating systems there, and this is Manitoba's view on the situation available at that website. Let's move on. Let's go to the next one. All right, so there's another one. That Manitoba Hydro, it shows over a 10-year. The dark blue is propane. The next squiggly line on the top there is fuel oil. Electricity is the blue line, which is relatively straight. Variable capacity cold climate air source heat pumps is the next one down, and only bested by natural gas and ground source heat pump for cost. And again, natural gas being the fossil fuel, but right now it's very inexpensive. So just another view on a 10-year thing. It looks like from November 2011 to August 2021. Okay, let's move on. It's basically illustrating what we see as being, the heat pumps are generally a very good low operating cost solution, which gives you the added benefit of air conditioning in the summer. Here's another website. This is Nova Scotia. I've spent a little bit of time out at Nova Scotia, and I find that Nova Scotia is probably 5-6 years ahead of Ontario on the implementation of heat pumps. There is an unbelievable amount of heat pumps installed in Nova Scotia right now. It may have something to do with municipal or provincial governments. I won't go there and make my own comments on that, but but that's recently changed as Nova Scotia just became conservative this last election. But anywho, that's a great website. It's got a lot of great information. They've actually got an estimate sheet on there that you can put in the square footage of your house, how many stories, roughly when it was built, and what the current heating source is. And so I threw in 1,600 square foot, 2-story home built after 2000, so fairly new with relatively updated insulation. Mid-efficiency oil furnace boiler, which is relatively common on the peninsula. So let's move on to the next one and see what that little calculator spit out for me. So the annual operational savings, anywhere from $580 to $710. Again, the insulation is a very important factor in this. Is the better your insulation, the less effect of upgrading a heating system may be. So this is 2000 or newer. If you had a house, I actually did run a scenario where the house was 1975 up to 2000, and the insulation quality is much less than after the year 2000. And I think after the year 2000 is when the energy tight homes really started to proliferate. So 75, and the savings from older homes was twice of this. So anyway, estimated, when it talks about estimated number of heat pumps needed, that's either individual heat pump systems or heads. And that was because this is a 2-story building that I put into the scenario. So we can talk a little bit more about number of heat pumps later on. This is the capital cost of the heat pump, anywhere from $6,450 to $10,750. I mean, depends an awful lot on the efficiency levels, the performance specifications, the brand, and pretty much everything's equal given those characteristics being equal. So the price is not that bad. Now, the environmental benefits. Some of these address what Ryan was mentioning at the beginning of the performance or of our presentation. CO2 emissions. So this is a home, a 2-story home, 2000, built in 2000 and later. And so they're estimating saving 1.57 tons of CO2 emissions equivalent annually. So I think that's a good thing. The same as removing 0.23 cars from the road, 3 cars over the life. And you can see some of the specs. As I say, back on that website that was on the previous slide for Nova Scotia, it's an interesting thing to see what, if you put your own home in there, based on the age and what you've got currently for heating, and just to see what the savings would be with the heat pump. Okay, let's move on to the next one. So now we're going to get into some different types of heat pumps. There's a few broad category divisions of heat pumps. Probably the main one, if you're considering one, is ducted versus ductless. Do you have a furnace, a central furnace in your home right now? Chances are you've got ducts attached to it with going to registers in your floor to cold air return, and it blows, the heat blows up in various rooms. So with these systems, you can either adapt to the existing duct system that you have, or, if you're considering, really putting some really looking at upgrading your home, you can actually install a duct system. And it's you know, it's a little bit of money, but it's well worth it for heat distribution and efficiency. So the systems again that you can have with a duct are something with a heat pump. You can actually get a heat pump to plug into your ducts. So you're replacing your fossil fuel furnace with a heat pump, an air source heat pump that's ducted. There are hybrids out there. So one of the things we'll talk about a little bit later on is the limitations of heat pumps and what you need to consider. And one of them is a backup or another source of heat. So they've got some very interesting, very high efficiency hybrid systems where you have a propane furnace on the peninsula, or a natural gas furnace, you know, in Wyerton South, wherever, a gas furnace, and you've got a high efficient heat pump attached to it. Or you can go all electric with an air handler and electric strip backup for the ducts. But there's a wide range of extremely efficient options for somebody with a duct system. Or if you don't have a duct system and your electric baseboard, or say you're a boiler system with rads or in-floor, then we look towards a ductless system. One of the considerations of a ductless system is how the different indoor options will look. There are a number of options. Everybody wants their house to look pretty and, you know, aesthetically pleasing. There are a variety of indoor options, and, you know, again, the efficiency is well worth looking at these. Okay, let's move on to the next one. Okay, so the next broad category of decision on the ducts is if you're to go, so the ducted systems is one main thing to replace your central furnace. That's your oil furnace or your propane furnace. You pull that out, you throw a ducted system in there, which will be either assisted or primarily heated with the heat pump system. If you're going to go ductless, now you have a choice between a single versus a multi. A single unit, as it kind of alludes to, is a single outdoor unit with a single indoor unit providing your heating and cooling. Multi-units have two or more indoor heads. They actually have, with the heat pump systems, you can actually, I've seen systems up to 9 indoor heads. So it's a very complicated and, you know, not an inexpensive system, but you can actually put 9 separate indoor heads off of one outdoor unit. Generally, they're less expensive than multiple single head units. So earlier in the slide, I think, or early in the slides, it talked about, you know, a minimum of two head systems. And that can either be a single outdoor unit with 2 indoor heads, or 2 single head units counts as a 2-head system if you're looking at the federal rebate. So there's a variety of options. We'll go into some of them in a couple of slides here. Single zone systems are the easiest to install. It's 1 indoor head, 1 outdoor head. Usually you can put one in far less than a day. They're actually, in my mind, they're the best bang for the buck, most economical for a single area. And that's the limitation, is if you have an open concept on your first floor or your second floor, a single head will probably do very, very well. But as you get more and more boxed in rooms, depending on insulation levels and things like that, then multiple heads are probably something to look at. Again, we require a minimum of 2 heads to qualify for the rebate, but those 2 heads can be 2 single head systems. So you have 2 outdoor units with 2 indoor heads. And the benefit of that, one of the benefits of that, is redundancy. So if something were to happen to one unit, you've always got the second unit to run. Again, a little bit more expensive. Interestingly enough, when I go out to Nova Scotia, quite a few of the houses have two single head separate systems instead of one outdoor unit attached to two indoor heads. And again, I find it that way to be a little bit more expensive, but then the redundancy is, a factor to take into account. Sorry, Ryan, let's move on to the next one. All right, so the third categorization, I don't know if that's the right word or not, but the third thing to look at is the performance levels of the heat pumps that you're looking at. Okay, so essentially, most manufacturers offer two separate heat ranges. And when I'm talking heat ranges, I'm talking the outdoor ambient temperature. So again, what a heat pump does is it pulls the heat energy out of the air from outside, which naturally is a little bit more difficult the colder it gets outside. So a standard unit is, I'm going to say, primarily if you have a very tried and true, inexpensive primary heat source, maybe a high efficient propane furnace or a boiler system or something that's very efficient with fossil fuel, and you're very happy with the heat and you're just looking for supplemental heat in the shoulder seasons, such as, when the temperature is above zero, but cold enough that you want to turn a heat source on, such as overnight, over the last couple nights, starting to get kind of cool out there. And you get the air conditioning with it. So they're a little bit less expensive. Generally, they claim to heat down to minus 15 degrees Celsius, outdoor ambient temperature. But one thing that you always have to consider is performance drops as the outdoor ambient temperature falls. And each manufacturer has literature of tested scenarios where they've tried to see what the heat output is at various ambient temperatures. It's always a good thing to try and ask for that. If your contractor doesn't provide that, it's something you want to ask. You want to say, it's a 2 tons system, which is 24,000 BTUs of heat transfer. At what temperature do I get 24,000 BTUs? And that's just the amount of heat that it'll put out. Do I get that at 0 degrees? Do I get that at minus 5 degrees? Do I get that at plus 5 degrees? And then as the outdoor temperature falls, that 24,000 is going to start falling as well. And these standard systems generally start running out of heat as it gets pretty close to the minus 15 Celsius. They're still going to provide heat, but it's going to be less heat and it's going to be a little harder on the electricity bill. But again, they're good for efficient AC with the occasional heating options. Times like this, great option. It's less expensive. So in Canada, we try and offer the cold climate version of these. So all the heat pumps, all the major manufacturers have a cold climate version. Some of them are called hyperheat. Some of them are called cold climate. Some of them are called low ambient systems. They're different names for the same thing. These are the systems that are designed to operate efficiency to a much colder temperature. Some of them will claim down to minus 25 Celsius. Some of them will claim down to minus 35 Celsius. Again, much better suited for the winter Bruce Peninsula operation, where naturally it gets cold in Canada. But again, you have to remember that performance drops as outdoor ambient temperature falls. But the performance is much better at the colder temperatures. So where, your performance essentially stops at minus 15 Celsius, you still got quite a bit of heat coming out at minus 20, minus 25. And then as it gets to minus 35, you still have heat, but now your supplemental source of heat, your other source of heat in your house, may have to help things out in order to keep you warm and comfortable. I'll tell you, now's a good time for a little story, a little side story. 3 years ago, so we've been putting heat pumps into people's houses for, I think, 8 years now. 3 years ago, I had a customer back out of a single head cold climate. It's actually called a low ambient train system, top of the line, single head, 38 SEER, up to 15 HSPF. So a very, very good unit. And the customer basically, said, I don't want it. I'm backing out here at the last minute. So I said to my guys, why don't we put this in at my house so I can walk the talk and I'll know what I'm talking about. So I have primarily heated with wood, with propane backup over the decades where I am. And I put my single head heat pump system in my room with the fireplace. And that was 3 years ago, almost to the date. And I said, the first winter, I'm going to track all my heating costs. I'm going to track my propane cost. I'm going to track my wood cost. And I'm going to track my electricity cost just to see what's going on. So I know what I'm talking about. I haven't put a stick of wood in the fireplace in 2 winters because I'm busy and basically lazy at times. And I was going through 7 face cord of wood on average per winter in that fireplace. So I don't know if you guys bought wood, but that's quite a bit of money right there. And as I say, not a stick of wood. My propane bill or propane usage, which is kind of at the back third of my house, dropped substantially. My hydro bill, again, fluctuated kind of here and there. And then the shoulder seasons, it was unbelievably inexpensive. And then February hit and I got a little bit of electric bill surprise because of the cold weather. But I tracked my costs for 6 months from the beginning of October to the end of March. And that first winter, I was $800 for the good. So it's a substantial savings. Okay, we'll move on. Enough about me. Okay, thanks, Ryan.
That's good. Those are the stories we want to hear, Eric.
It's fantastic. It's just the greatest heat in the world.
Sorry, there's a bit of a delay on switching the slides. There it is.
That's okay. So now we're going to get into some of the indoor options. I'll try and show some pictures. What most people are familiar with ductless systems is the high wall units. They sit high up on the wall, hence the name of them. And some people don't mind the look. Other people find them aesthetically not so nice, but they are the most efficient at the best cost. If you're looking for a good basic system to get efficiency and heat and air conditioning, that's the way to go. They're the best sort of thing. There's some special features and designs are available, depends on manufacturers. Some of them are equipped with an infrared eye that sort of will watch when somebody comes into the room, and then they'll ramp up and warm things up in the wintertime or in the summertime, cool the room when they know somebody's in the room. Some of them, the technology is so good as they can differentiate between a person going in the room and an animal going in the room because of the temperature, I guess, infrared. So the value of that is when you leave the room, the system ramps down just to save that much more energy. It says, I don't need to keep this room at 72 degrees. I'm dating myself with my Fahrenheit, but with the warmth or the cooling in the summer, I can relax a bit because nobody's there. And then the infrared eye sees somebody coming in, and then it sort of ramps up and starts cooling like it's supposed to. Other features are some diversity in air delivery. So they have indoor dampers that not only will make the air, go from the floor to the ceiling, but some of them will actually direct the air left and right. So it's a box on the air and it'll direct the air back and forth. When I'm talking about design, again, most of them are the same rectangular box on the wall, but there are manufacturers that have tried to modernize the look. of the indoor head, and they've added some, you know, nice curves to it. And I won't name any manufacturers right now, but there are some nicer looking indoor heads that are available to help keep the aesthetic end of it up. Okay, let's move on. All right, so here's 3 of my best systems that I'll put in. There's Daikin, Train, and Mitsubishi down below. You can see the indoor heads. They kind of all look very similar. Nothing fancy. At my house, mine is a high efficiency, top of the line Train. And to get the additional efficiency, like the very, very high efficiency, that indoor head is actually oversized to increase the efficiency. So when I first put it in, it was a little gaudy where I had it, but you know what? Eventually you just become used to it and you don't even notice it's there, except for when it's blowing nice warm heat on you when you walk by. Okay, so there's a variety of the standard indoor heads. Let's move on. So here are some other options for indoor heads. Okay, so if we start at the bottom left, that's a low wall indoor system. So that basically goes on the bottom of your wall. This is a nice thing for a lot of attics that have pitched ceilings because of the pitch of the roof. So you haven't really got a high wall to put a high wall unit in there. This will go low on a wall, very, you know, relatively flat to the wall. It may sit out 2 inches, 2.5 inches. Doesn't look too bad. It's a Train unit, but you know, the Mitsubishi units and the Daikin units all look very similar to that. The lower middle there, that's called a ceiling cassette. And that's not the best look, but if you were to Google ceiling cassettes, they are extremely nice looking. That one's probably the least nice looking one I've ever seen, but it's a good picture in a tiled ceiling. So they sit in your ceiling. This is, you have to have an attic space above in order to get it in there, but it sits straight on your ceiling. So you're not looking at the walls, and it provides the heating and cooling gently from in 4 directions off of this thing. I've been in quite a few hotel rooms actually that have something similar to that in the ceilings of them, and they're just nice. You don't notice it. If you do notice it, it doesn't look bad at all. Over to the right there, that's the air handler. So that's an electric air handler. That's for a ducted system. So again, if you were gonna eliminate fossil fuel completely, that would go in place of your furnace. And what we would do in Canada, or you know, Bruce Peninsula, is you'd have your heat pump plugged into that. That's actually a Zuba system, which is a very high-end Mitsubishi system, very, very, very efficient. And the heat pump on a Zuba system will work pretty efficiently down to like -30 degrees and back to the backup heat. So now for a system like that, the backup heat would be an electric strip, which would go in there and just supplement the heat output as it gets colder outside. So as you're approaching -30, a couple of banks of electric. But on a Zuba system, the operating costs are so inexpensive. And that electric strip is just the backup, just to help things out if it gets too cold, to keep your bills down and keep you warm. Up on the upper left is something called a concealed ducted. So we've put in quite a few of those actually, and they work really, really well in an attic. So in an attic, you can add some insulated duct on one end of it. And again, so you can have one heat pump unit sitting up in your attic, and you can feed, you know, 3, 4, 5 rooms that's sitting on the top floor of your house. You don't see it. All you see is a couple of registers in the ceiling, providing very efficient heating and air conditioning. Very good solution for a lot of houses that have good heating system on the first floor, nothing on the 3rd floor at the top with the attic. And it's, you know, very, very, very hot in the summertime. You know, it may be cold in the winter because nobody's taking the time to run any duct work up there. So it's a really good solution for that. Let's move on. Okay, so this is kind of an intermission. Okay, get some music going. So there's my email address, eric@crosemechanical.ca. If any questions have come to mind, just send me an email. I have no problem responding to anything that you ask. There's our website and our phone number, and hopefully you can remember at least the email for the questions. Okay, so we can move on from here if everybody's got that.
I had one clarification question in the chat here, Eric, if you don't mind.
Nope.
So Anna just wanted to clarify that a ducted system also does air conditioning.
Yes.
They do. Okay.
You get any type of heat pump system. It's a side effect that comes with every one of them is air conditioning.
Great.
Okay, let's move on.
Sorry,
okay, so these are the questions. Pardon me? Okay, so these are the questions that Ryan shared with me earlier. So question one of the concerns is that heat pumps is that they don't work when the power out is out. This is true, but it's also true of your propane furnace and your oil furnace and pretty much, well, everything. Everything requires hydro. So, I mean, there's really no way around that. There are alternate sources of heat, such as some propane fireplaces and some wall furnaces that can provide some heat. But this is why, one of the areas that we've been pushed into is generators, as more and more people are looking for backup generators. So yes, if the heat pump goes out, if the hydro goes out, your heat pump goes out as well with everything else. The electrical panel requirement for a heat pump depends on the size of the heat pump, depends on the performance measures of the heat pump. The ones that go down to cold temperature require more amps because it has to ramp up in order to pull the heat from the colder temperature. So the full ducted systems tend to require more breakers. It requires more breakers to operate. There are ways to minimize that, but there is some electrical panel requirement. I know there are quite a few 100 amp panels up the peninsula. There are heat pumps that we can install, but they're generally more of the standard size, which requires a less hydro draw. So that's something to take into consideration. If you're thinking about a heat pump, is what's available on your panel, what size of panel, whether it's 100 amps, there's even 60 amp panels out there, which is, again, not necessary. I don't think we can put a heat pump on that, but 100 amp is questionable. There are some single head systems that don't require that much. So for efficiency and to help out, you have an open concept, a well-placed single head heat pump system might be as low as 20 amps. But again, a full heat pump system, the full air handler requires a lot more hydro. And then if you have electric backup, that's another double pole breaker on top. Some HVAC installers seem to recommend against heat pumps. Why is that? There is certifications required. You are supposed to have at the very least, a residential air conditioning ticket. I have a full industrial refrigeration and air conditioning ticket. So you are supposed to have some certifications. I think one of the reasons a lot of installers may recommend against heat pumps is because a lot of installers have been in the industry for a number of decades. And as I mentioned at the beginning, their performance of heat pumps back in the 70s and the 80s wasn't that great. So they tended to take a lot of hydro. They did not perform very well. And again, if you're stuck in the past and don't keep up with the newer technology, that can happen there. So, and also a thing with the things is you require a backup source of heat. You cannot sorry, you can, but manufacturers and quality installers will highly recommend not pulling. If you have electric baseboards and you want to go to a heat pump, that's fantastic. Don't rip out all your electric baseboards. Keep a couple just to help out when it gets very, very cold. I am a huge fan of always having a backup. I just to share with you, at my house, I have the heat pump, I have a propane furnace, I have a backup oil furnace, I have backup wood, and I have backup baseboards. So I'm never going to be without heat. So you have to have a backup. So the other question, I have no ductwork. Yes, so there's different ways that we can snake the lines to go to the indoor units. Generally, it's on the outside. We cover them. We try to cover all our installations. We try to with things called line set covers, and they're just plastic. They look kind of like eaves troughs. They're just plastic straight lines. They have right angle elbows. They're paintable. There's a variety of colors. You know, often you match the trim of your house. I think they look quite nice. Much better than having the lines bare naked running all over your house. I mean, if it's a good installation, it's going to look good. Hope that helped with some of those questions. I know some other questions came in. What do you think, Ryan?
Yeah, do you want to tackle some of those now, or do you want to save them till
Sure.
the end?
Well, let's save them to the end. Okay, let's move on right now.
Sure.
Okay, here's just a couple of systems. This is a Daikin system, very nice system. Bottom left, there's the central air handler that replaces your furnace. Low up above that's the low profile outside unit. To the right of the central air handler is a high efficiency filter system. The next little item is actually an air quality monitor. So it goes in your ductwork and will monitor the quality, any particulates in your duct system. Good for humidity as well. And besides that is a very high-end smart Wi-Fi thermostat that can be used to tell you wherever you are, the quality of the air in your house, quality of your heating, the temperature, everything. It's actually a fantastic system. Let's move on to the next one. Here's a Mitsubishi Zuba system. As I was talking about the performance metrics of those earlier, very, very high-end system. We put in several of them. The customers just love the operating costs. You know, it's upfront cost, but I mean, once you get it in, it's so inexpensive all year round, air conditioning and heat. Let's move on. Train system. Notice the heat pump on this. The train does have a side discharge. Let's just move back just one, Ryan, if you don't mind. So a lot of these that we're talking about look like this with the fan blows the air horizontally out. Generally, with the new ductless systems, that's the way they are. They're extremely quiet. They're high efficient for a number of different technical reasons. And then let's move on. So this is a vertical discharge heat pump. This one is a picture of an XV20, which is a 20 SEER and at least a 10 HSPF. So extremely good. This one is extra battened down to keep things quiet, but they have versions which are side discharge. It's just Trane has a lot of these systems which are vertical discharge. Extremely good, extremely high efficient. Again, here's an air handler with it and a furnace, maybe for a hybrid system. Let's carry on. Okay, so if you're doing your research, you may come across the terms VRV and VRF systems. These are essentially the same technology, and it's called variable refrigerant volume or variable refrigerant flow. This is the next step up in efficiency over the ductless and the heat pump inverter systems that I've been talking about. These are fairly new on the residential side. They've been in commercial buildings, higher end commercial installations for a number of years. extremely efficient. So now you're going beyond your 10 HSPF and your your 20 or your 23 SEER. You're even more efficient. We've actually installed one of these on the peninsula just recently. We've just finished it up. And so we'll see whether I can walk the talk or not. I'll know from the customer soon how things are working, but again, a very high-end, very good system. A couple of advantages that we'll move into on that. The only problem is that, so the problem with the federal rebate, which I haven't really got into during the presentation, is the government did not take the time to test all the available systems. They basically took a sampling of various manufacturers, stuck it on the list, and missed a whole bunch of stuff where the manufacturer, which easily meet the criteria, but the manufacturers are lobbying the federal government to great extent in order to, open up the product list a little bit more. So there are extremely high efficiency systems, such as these VRV systems, which are not on the list and therefore don't qualify for the federal rebate. So let's move on here. So here's a VRV system. So on this system, you can have your air handler in the basement. You can have your ceiling cassette in the attic to do your upstairs bedrooms. You can attach a couple of high wall systems, a low wall system. You can attach all these various systems to one outdoor unit, and it's extremely efficient. There are some other manufacturers that come out with this. I guess, again, if you're doing your research, VRV, VRF, it just, at this time, they don't qualify for the federal rebate for the reasons I told you. Okay, let's carry on. Okay, so these are the cautions with heat pumps. Again, I have to say it again and again and again, heat pumps are not your primary heat source. They are excellent, can't even get the word. Excellent heat sources to assist a primary heat source. The value of a heat pump, and I think I saw a question float by here earlier on this. The value of a heat pump is there's really no better way to maintain the temperature in your house for efficiency, low cost. They are not that good for raising the temperature. So I think what somebody said is, what if I go away and turn all the heat off? Or I go back to, a place down south and I come back on weekends and I want to heat my house up with a heat pump. They are not a good source to raise the temperature. They are fantastic to maintain the temperature. So on a ducted system, if you decided to replace your furnace in your basement, hooked onto your ducts, that's where that electric strip may come in handy, or a Wi-Fi thermostat. So the heat pump will bring the temperature of the air up gradually. As they say, they're meant to maintain. The electric strip will boost it in a hurry. If it's a hybrid system attached to a propane furnace, again, it'll boost it quickly and then it will shut off, and then the heat pump will extremely efficiently maintain that heat for as long as it is. What I do at my house, where I put the single head in where the fireplace is I leave mine set at the same temperature, give or take 1 or 2 degrees, for the entire winter, the entire cold months. I set it and I forget. And as I say, my bills are just like unbelievably low. And it maintains my temperature in my house. I walk by, there's warm air going through, but I don't shut it off and then try and raise the temperature back up, because that's not what they're for. They're not good at that. So again, on ducted systems, you got a fossil fuel furnace, or you have an electric furnace, baseboards, wood stove. A wood stove is a good thing. Again, the trouble with the wood stove is you have to be relatively close if things get really cold, but I mean, it'll boost the heat. The gas fireplace is an excellent accessory with a heat pump. Highly recommend it. I think it's a great combination. The gas fireplace looks good. You arrive, you know, from being away, click, your fireplace comes on, it rapidly heats up the area. Then you can turn your gas fireplace down and your heat pump will maintain that temperature. The other thing you got to be careful of is clearing the snow. So the way a heat pump will work, because again, it's taking the heat from the outside and bringing it inside. The air blowing through your outdoor unit is going to be colder than the ambient temperature. Think of it as an air conditioner in reverse. So in an air conditioner, you have cold air blowing out of the inside unit. On heat pump, you have cold air blowing out of the outside unit, colder than the ambient. So what that happens is any moisture in the air will freeze to it. So the heat pumps are designed to go into a defrost system to clear that off, and it will go in quite frequently the more moisture is in the air. So right around 0 degrees, there's a lot of moisture in the air and your heat pump will be in defrost quite a bit. Again, you get used to it. It just takes care of it. But as the snow load builds up around it, I mean, it's not going to do well in 6 feet of snow around the thing. So just keep in mind, clear the snow away when you see it, and it'll continue to give you lots of years and times of staying warm. Let's move on.
I've seen pictures of people who build little doghouse shelters over top of their heat pumps outside. Does that work, or would you recommend against that?
Nope. Some manufacturers actually have a one that's made for their system. I've seen some very creative dog houses over the systems, and you know, the owners of them swear by them. They said that they're absolutely fantastic. You know, as long as you can get the airflow, maintain the airflow, anything you can do. I have one guy in Sydenham Township, which is not on the peninsula, but he's built an entire porch and like a hot tub area. He's built an entire structure around his heat pump in order to maintain the ambient temperature as high as possible from leftover heat loss from his house and from the hot tub and everything. So it keeps the ambient temperature around his heat pump, which means that it works less hard at colder temperatures. Like he's amazing what he's built around this thing.
Very clever.
But anyway, yes. Okay, we can move on. All right, so here's my small little talk about the federal rebate, greener homes. Point one, do your research. I mean, there's loads of information on the internet for greener homes. The first step is always to call an authorized energy auditor, because no matter what you're going for, you need to have an energy audit on your home. The auditor, good auditors, will also answer a lot of your questions. So, I mean, this is their job. Next step is to get quotes. So heating is one aspect of the federal rebate. There's insulation, you know, there's windows, there's all kinds of things that qualify for different levels of rebates. Even though I'm a heating guy, but I honestly know that replacing your heating system is not necessarily the best way to increase efficiency. It is a good way, but a better way, in my personal opinion, is insulation and windows. So just, you know, keep that in mind. Heat pumps are a beautiful thing, but, you know, make sure your house is tight. Oh, I got to go back.
Sorry, my fault. Yep.
What happened?
Still
okay.
there.
Okay, so you and your contractor have to ensure that the quoted equipment qualifies. It should have an HRI number, and it has to be on the NRCan list, which is on the internet. Again, I mentioned this earlier in the presentation, there are a lot of very high quality systems that did not make it onto that list. Just because it is super efficient doesn't mean it made the list. It must be intended, the system must be intended to heat the whole house. You need a minimum of 2 indoor heads for ductless. You get the work done, then you're required to call your energy auditor again. He comes back, charges you again, says, oh, good job. You got a ductless heating system. You did some updates, and then you go for the rebate after that. Okay, let's move on. Okay, so there's a little bit of stuff about our company. We offer a yearly maintenance protection plans where we look after your equipment. Give us a call. This is not an advertising thing, so we'll just move on, just letting you know. Moving on. CroseMechanical.ca. I gave you my email address for any questions. No sales pressure or anything like that. I enjoy talking about this stuff. Part of my background is, as I'd say, my qualifications, and I used to teach. I taught at the college for 10 years as well. And as you may have noticed, I like to talk about this stuff. So, any emails or anything, I'll answer any questions you've got. And speaking of questions, I think there were some extra ones there, Ryan, that came in.
Yeah, how about I read through a couple of those and we can see how many we get through before we run out of time. How's that sound?
Great.
All right, so I'll go with the first ones we had. It was from Tom. He says, will the ducted system also remove humidity?
Yes, on air conditioning, side effect of air conditioning is it removes humidity. A lot of systems actually have a dehumidification setting. And the difference between regular air conditioning and air conditioning to remove humidity is the speed of the fan over the airflow over the coil. So the coil or the fan actually slows down in dehumidification mode, which allows the warmer, moist air to be in contact with the cold coil longer because the speed is slowed down, which pulls out that much more humidity out of it. So yes, they all have that mode, that option, and then the air conditioning will do a certain level of dehumidification. If you're not getting the dehumidification in your air conditioning system, I can almost guarantee, like in your existing air conditioning system, I can almost guarantee there's an airflow problem somewhere. Give us a call, we'll walk you through it. Okay, next one.
All right, there's a few there that we've already covered. It looks like there's one from Rod here, who I actually know. I've seen his system. He has an air to water heat pump system. So it's an air pump to an in-floor heating system. And so he was just wondering about other heat pump options to hydronic heating or water heating.
So yes, there is the air to water. Rod, I think you contacted us, and I got to give you a call to have a look at your system. So we're in the process of putting another one of those systems in, air to water for the in-floor heat. Seems like a great system, relatively new. I hope we can carry on with those. And I'll give you a call, Rod, when I can get up that way, and I'll stop in and we can chat, okay?
Sure, that'd be great.
Yeah, no, I appreciate your contacting us there a little while ago. As I say, we have a new system that is not totally in yet, but we're working on it, and we're quite excited to be able to offer that.
Is that the same people I use, same equipment I used, or something else?
Absolutely. Yep, no, the same company.
Good.
Yeah, thank you.
Great. So Jerry asked, do you qualify for rebates on a new build or only when upgrading? As far as I know, it's only when you're upgrading, because you need to have that energy retro or the energy audit done, which you can't get done on a building that isn't built. As far as I know, is that about right, Eric?
As far as I know, yes, that's a question that I would always put towards an auditor. I know, again, we know a fair bit about it, but we don't know everything about it, but that makes total sense, Ryan.
The next one from Christina, she says, with the hybrid system, where is the system drying in the air? The furnace is in the crawl space, not the best air quality. So there'd be an outdoor unit for that as well, right?
Well, so yeah, so for a hybrid system, your furnace in the crawl space should not be drawing air from the crawl space. It should be ducted on the return side up to the living space with a return air opening one or two or however many has been done. So you should not be pulling the air from the crawl space. You should be pulling it from your living quarters. And then it pulls down through your furnace, through your heat pump if it's a hybrid system, and then back up through the ducts to the registers. Yeah, if you were pulling air out of the crawl space, you should probably give somebody a call for that.
Susan was asking about if there's provincial rebate programs to be stacked with the federal one, and I think I know the answer to that one. It's no, there isn't right now. That there were rebates for incentives for heat pumps a couple of years back in Ontario, but right now, as far as I know, that there's no Ontario rebates.
Right, now there are some fuel companies. I think that Enbridge still has some rebates available. I think Enbridge has some rebates, and I think the IESO, which is the electrical thing, may have a couple still. But again, the best source of information, it'd be Ryan or your energy auditor.
Yeah, so as far as I know, the Enbridge one is only if you're switching to a higher efficiency fossil fuel system, the one you already have, so not switching to a heat pump, and the IESO one was discontinued.
Oh, okay.
It's too bad because they're great programs.
Something to do with the conservative government, I think.
It seems to line up that way sometimes, yeah.
There's a correlation there somewhere.
Someone Viscount says, any ideas about finding an auditor that will come up to the North, Bruce? So yeah, that's something that I've been working on a little bit with my position with the Biosphere. We're severely underserviced in this area. There is one auditor in Wyerton that I'm not sure he's even doing audits right now, but I'm meaning to reach out to him. We're working with a organization called Green Communities Canada. They're out of Collingwood, and they've offered to send up their auditor a few times over the next couple months to do audits for us. If you want to learn more about that and that process, I can send out a mass email to everybody here afterwards and kind of walk you through the process for signing up, because before you get your audit, you actually need to register your home on a federal website. And so I can send out some more information on that afterwards too. Friends.